Hi everyone, welcome to the Data Driven Supply Chain Podcast. Today I have a fantastic student, Behrad, that already has internship and is currently working in mechanical engineering. Behrad, thank you for being here. We had a great discussion before. Can you introduce a bit your background and like where you studied and everything and where you're at right now to people listening?
Yep, for sure. Hi, my name is Behrad. Thanks for having me. Of course, it's my pleasure to talk to you. I mean, we had the opportunity to talk before, but this time is a bit different. We're sharing this with people, this discussion. So I'm so happy for that. I finished my third year mechanical engineering at TMU. I'm currently doing my co-op this year for a year with the MHICA in Mississauga. And that's pretty much it.
Cool. Nice. And I've seen that like you said, pretty much it, but there's a lot of stuff that you were doing. I see that you were in the rocket science club in university, that you did research on top of studying engineering. Well, first, can you talk to us a bit about this part and how do you find the time to do all of this? Because I know engineers and I know people that are going for engineering, and
Yeah.
some of them are like, that's the only thing that they're doing is like studying and that's it. So what's your secret here?
Well, to be honest, it was super difficult to manage. Not gonna lie. I don't wanna I don't wanna remember those days, but we can go through them for sure. So yeah, it was definitely it was challenging and it was difficult because I had six courses, and then I think I took over the position in September 2022, right?
Okay.
I never had the experience leading a team engineering design team. Of course, it's a challenging experience. I was on the team, but as a member, just as a member, and I kind of tried super hard to expand my knowledge and like
Mhm.
in the field, aerospace field. I mean, I'm studying mechanical, but I always wanted to pursue a career in aerospace engineering. That's why I joined the rocketry club at our university as a member, and then applied for a bunch of positions. They offered me the um, recovery lead position
Okay.
uh, back in September 2022, and I took it. I took it, and it was difficult to manage because it was a big sub team, like the recovery and the staging. It was a big sub team, and we decided to do the one stage rocket that we always do, in addition to a two stage rocket,
Okay.
and that made it a bit more challenging as I was new to the team. I was new to like the idea of design with a mechanical background, not even with an aerospace background. So I had to go over a lot of stuff myself to kind of expand my knowledge in the and the design aspect of aerospace. But then the research opportunity popped up after a month, so I took that as well. You might say why. The reason is that the first 2 years were online for me, right?
Okay.
So for everyone, of course. So we did not have the opportunity to network, expand our knowledge in terms of like practicality, of course,
Yeah.
as it was online. And I really wanted, like, I always wanted to succeed in this field. I really wanted a good internship, a good co-op, and I really wanted to be a technical engineer, not
Yeah.
only like management stuff. So that's why I tried my best to get exposed to research, like design, um, and everything as much as possible. So so I would I would be able to apply it in real world, like the theory that I've learned throughout the years of engineering school. So that's why I did this to myself.
Yeah.
But definitely it worked, and it helped. I never thought it would help this much. I had multiple offers from big companies,
Yeah.
had interviews with big companies, and that built up the confidence, and I saw that yeah, I can do it. So um,
Exactly.
yeah, it
And
meant a lot, to be honest.
and I think one of the core skills that you develop here is something we've talked about previously, is that like taking on challenges that you're just gonna figure it out, but you kind of know you can
Yep.
figure it out.
Yep.
These challenges, that's the best. Taking a challenge, which you already done, it's not really a challenge. Just like you're just doing this again. But like these things where you know it's a leap, but you actually want to do it and you want to get there, that's where the real learning go for. Like I remember I like this story because when I was in doing my bachelor, I did the same thing. I had a full course load, like I had a 5-6 course. But one thing that drove me when I was studying was all the research stuff. Like all of the research stuff, I was like, this is cool. I want to learn that more. But it's in the classroom, like it stops and then it's just theoretical or whatnot. I wanted to be like doing that stuff. So I just emailed a bunch of professor, and it's just like went into a lab, started doing my research, and then they offered me like to conduct my own research in this lab, and then I went to another lab in the summer. Like, and I was just kept doing what exactly I wanted and where I wanted to be, and that like I had much more confidence to do like anything really. At some point, I was in lab. Doing molecular biology. I never went in the lab before. And now they told me like, hey, first day you do this and that, and I was doing it. Like at this point in time, I was like splicing gene and like putting like making them grow and all this stuff, doing my PCR to get my protein and all this stuff. Um, Everything that I was reading and then I was looking at in courses, I was able to do, and it made two things happen. First, my confidence shot up, and I knew I could do like stuff that I never did before, but I wanted to if I could figure it out roughly how to do it. And second of all, it made the rest of the things that you're doing, let's say like when you're in a class and stuff like that, much more easy. I was like, this is less worse than everything I'm gonna do in the lab. It's way less. There's a solution for this, and it's somewhere in the textbook. So can you talk to us a bit about that part? This specifically when you were doing research. First, like what was the research about, and how this skill that you developed helped?
Yeah. For sure. Yep. So thank you so much for the story. Yeah, the research was about 3D printing composite material. Um, I knew how to like I learned how to 3D print, how to run the machine, how to use slicing softwares, how to generate STL files and everything. And I had a good background in CAD using CATIA and SolidWorks. Um, so I knew how to print like stuff out of PLA, ABS, TPU. These are the materials that you hear them every day when we talk about 3D printing. But composite material is a new subject. They've done it, but we still need a bit of more advancement on that for sure. So the professor took me on the team, and then I had the opportunity to work on 3D printing composite material research, which involved a lot of sciences that we studied before. We did fluid mechanics analysis, we did the source analysis, we used our thermodynamics knowledge from before. At some point, I was doing a research on the reciprocating pumps that we had to use to kind of pump in the UV resin.
Okay,
That
wow.
kind of act like a coating around the fiber that comes out of the nozzle. At some point, I had to use my physics background because we had to use UV light to cure down the UV resin, right? So and at the same time, I had the opportunity to cat the prototype for the extruder that we would have put on the mechanical arm. So basically, the whole idea was to put the extruder on top of a mechanical arm that can print in definitely XYZ, and also in like curved paths, so that you get to print more complex objects and stuff. So yeah, and the whole idea was to kind of pump in UV resin, and then using a mechanism get the fiber out of the nozzle, and pump in the UV resin which coats the fiber.
Okay.
And then that fiber, the coating, which is the UV resin around the fiber, gets cured down using UV lights, UV light or lasers that we use. So we made the prototype, and we kind of tested it. It worked pretty well. And yeah, I had to use I did fluid simulation for that project. At the same time, as I said, I used SolidWorks to make stands and stuff for the UV for the UV lights that we wanted to use. So yeah, I applied a lot of stuff that I learned from before, but I had to definitely I had to kind of expand my knowledge and my skills.
Yeah.
To kind of proceed with the research, right?
Yeah.
So yeah,
Definitely.
yeah, that was challenging because it's graduate level research. I was doing undergrad,
Yeah.
totally different. And for example, Bernoulli's equation is gotta meet like 10 conditions, right? But once you put it in practice, you don't have those conditions. So it's,
That was fun when you get to actually like using these stuff in a
when
non-control environment, and you're like, what the hell I'm supposed to do? Like, what
that's
is
what I'm saying. When you put it in practice, you just realize that, oh, yeah, I used to solve it, used to work on the paper, but the new movie, did you watch Oppenheimer, by the way?
Yeah, I watched it like
Yeah.
2 weeks ago.
Theory can take you so far, just
Yeah,
so
exactly.
far.
That's it.
That's yeah. I love that quotation, by the way.
At some point, I've hit that wall at some point because I was given a bunch of data to like do analysis on, and then like, cool. So what should I do? And then my PI was like, well, we tried a bunch of stuff and it didn't work. I mean, like, here's a bunch of papers, and like just try to come up with something like that, like some analysis and stuff. And then my mind went like, boom, like, what do you mean? Like, I can just mix and match stuff. I can just think about it and then just like, and like, yeah, and try it. And if it doesn't work, then just try again. And that's the part that is absolutely fascinating with research, is the amount of just messing around and then just trying to like actually get it to work and make it fit.
Yeah.
And you get something sometimes and sometimes not, but sometimes you get something and you're like, why? Why did I get something out of it? Why this thing worked? And that's the most beautiful feeling I had in my academic days, is when you actually think it through and then you kind of see a solution for it, or you make a prototype and it actually work. You're like, wow, I've put all of this together, and with a bit of sprinkle of trying stuff out and figuring it out, and it just hold together, and it's actually helping. Fantastic, I love that. And like, if you transition from this to now the work that you do as part of your internship, so can you talk to us a bit more about your work at Mitsubishi Heavy Industry, and like exactly how these experiences that you've done help you on the day-to-day right now?
Yeah, I have a good story, by the way. It was like, I think it was my third week in the company. So my manager sent me a case of a study, a case of investigation. There was a crack on one part of the aircraft. The reason that I don't disclose I don't know if I'm allowed, so that's why I
Yeah,
didn't
it's
disclose the
good.
course,
Keep it as this.
the case of investigation. Yeah. But yeah, he sent me a bunch of pictures with all the information on what happened, and just asked me to find the root cause of this issue at hand. So I looked at the crack. I looked at the position of the crack, how it propagated, and how it looks like. It was on a composite material. And then I thought about it. I did not go on the floor. I did not go on the to take a look at the part itself. I just looked at the pictures, whatever. I was like, yeah. So the radius is not much. The thickness is not much. So a stress concentration is more. So while they were handling the part, they pushed too hard, applied too much stress, and that's why it cracked. And I wrote everything like in a very good format, whatever. I wrote everything in a very good a structure and sent it back to the manager in the most like formal way. And then he was like, "This is not university anymore. You cannot analyze cases like that. You got to get on the floor, trying to find the root cause. This is not university anymore. You just don't look at the crack and just come up with your theories and stuff." So it's actually, yeah, the way that you gotta look at the problems at hand is it's totally different when you get on a manufacturing site, um, as opposed to university or research project. Definitely two different, totally different, two different aspects that you gotta apply. But yeah, I had those experiences too, but now I've gotten used to it. I go on the floor. I take a look at the case. I take to see if I can come up with a corrective action. What is the root cause? Well, what could have been better in terms of like can we improve the process to kind of avoid this? Was it operator's mistake? Was it tooling? Was it so? Yeah, you just consider all the factors that can be involved. That's how you look at it when it gets to manufacturing site and a business. At the end of the day, it's a business.
Yeah, exactly.
Yeah. But for university, no. It's, as you said, trial and error. Let's try it. Let's see if it works. If it works, let's proceed with the research. Let's write a report about it. Let's publish it. Whatever. That's not what you're looking for.
Yeah.
On
In research, you have like you have a wide even if it doesn't work, but it leads you here, it's kind of good. Okay, cool. We can keep at it. And some people hate that. Some people hate that aspect of like having absolutely no boundary whatsoever that is possible, and that's the thrill of it. But what I found is when you're actually doing work to get to a very very specific business point, there is still this. But there's a constraint applied to that system. Like in research, usually the constraint is like, can you get to something of value as fast as possible within a reasonable time frame ish. But in business, like we got to get this done, and like yes, there could be all of this, but like
time is an asset. Yeah,
I need you to get that specific thing done. But it's helpful to keep that kind of mentality when you hit certain type of problem where like there is no path. There's no way to go from A to B. Absolutely not. We have to actually find a path and then do that movement, and then you can actually hit it faster than everybody else because you're taking a bit tangentially and taking the rest of the stuff in there.
That's different. Yeah, that's true. I agree. And it's like just to add on something, you cannot, like, for example, there's this issue on the, let's say on the centrifuge, right? You cannot keep the centrifuge waiting for you till you find a solution for it.
Yeah,
time is an asset. You got to get the production line moving. It's not like research. One day you feel like it, you work harder to to kind of make more progress. The other day it's fine. You can just analyze what your findings were, right?
Yeah,
Put it into words. No, it does not work like this. You got to get it
exactly.
done because there's so many people waiting out there for you, and there's a big centrifuge waiting on the line that has to be delivered in a couple of days.
Yeah.
So yeah, totally different. You might ask me which one I would prefer. I wouldn't prefer one to
I
the
would have
other.
said the same. I would say it
Yeah,
depends. It depends on the
it
days.
depends. It depends definitely. But to be honest with you, I gotta, in all honesty, MHI has been the greatest experience I've ever had in my life.
Hmm.
That is something that I cannot deny. Yeah. So the way that I look at engineering right now is totally different uh, from the way that I used to think about it, like 4 months ago, for
Yeah.
example. And the way that I thought about the theory behind all this going, is the way that I think about it right now is totally different. Put it into practice, I would say it's the most beautiful thing ever. When you put in like a stress analysis into practice, when you put in, for example, the shear force applied on the fasteners or whatever, in practice, you just realize that yeah, now you're making connection from whatever you've studied before. You're making connection to get to a solution, and the feeling of it, it is unbelievable. I have to say
You
it is.
can see it. Like you can see, like, okay, my job here, I did that, and now this thing is over there. Like I could walk and see the stuff that I've helped fix the problem, whatnot. And like I'm not from aerospace at all, but I've been to a few aerospace factory line, and it's always amazing. In theory, you think about the airplane, you're like, okay, well, it's clean stuff like this. But if you get a tour of a factory by the head of production, um, uh, the chief of production, you will get the whole story. You will get the actual stuff and the
That's the thing.
problem, and then he will show you how he sees it. And one that I went recently, he showed me the whole thing, and there was a bunch of planes, like the cockpit, that were stalled into an
Mhm.
area. When I first came, I was like, "Wow, this is clean." But when he showed me the stuff, I was like, "Oh shit! Like this, there's a problem here. There's a big one. Their buffer section is always full." And then he told me, like, you see that this hole right there, and then show me a hole. And then he told me, like, everything was stalled because that hole, they require a part that didn't cost that much, but this part was not well painted to fit like the quality stuff. So like he knew where the part was, right? He knew where the painting was in his
Mhm.
shop, but he couldn't go and then just paint it,
Yeah.
and then he had to be sent back to the supplier for 9 days, and everything was stalled just for that. But
Mhm.
when you realize that throughout all of this engineering, if there's an issue like this or issue similar that has the same effect, the factory line can be completely jammed. And seeing that your solution to these like micro problem help like
Yeah.
clear the line and make them moving, um I mean, like this has to feel something good, right?
Yeah. Yeah. Definitely. It feels differently. It's it's a great experience when you see things, when you see the theory working, or when you see um, uh, how the production line works. And as you said, for example, you actually pointed out something important. I don't want to miss that. You said that if you get on the floor with the production guy, you
Yeah.
get to see everything. Yeah, that's the difference between engineers. Of course, when, like for example, for me, I'm sitting behind my desk, looking at the screen, whatever, trying to solve issues, trying to do projects, whatever. But they're on the floor every single day. They get to observe the process and in terms of practicality, and they get to observe it, whatever. So
they
they,
get they
they
get to feel
understand.
the process going through,
Yeah,
right?
yeah, they understand the process way better than an engineer for sure. But yeah, how to solve it is as an
It's
engineer.
difficult because like these things, like it's not one team or whatnot. It's like a whole Korean team that
It's a
need
big
to
team.
come together so that the flow works. Right? It has to be the engineer, it has to be the supply chain dudes, it has to be like the procurement
Yeah,
girls, it has to be all of these people understanding what's
yeah,
happening and in this production line to get to actually the plane leaving. Because if the
mhm,
plane stays there, it's not fun for no one.
yeah, yeah. There's actually this project that I'm super happy that I'm part of that. By the way, it's like the most like maybe the high profile project at the moment at MHICA. Um, and I had the opportunity to work on it. So yeah, of course, as a as methods, you get to as a methods engineer, you just get to do the investigation, find the root cause, come up with a corrective action and whatnot. But you tend to talk to the tooling guy throughout the process. You tend to talk to the stress guy, the stress engineer, and the process. You talk to SQE to see if the supplier did a good job, which is the supplier quality engineer. Right? You talk to the quality engineer to see. You gotta ask every single person because they're looking from a different perspective to the problem.
Yeah.
A design engineer does not look at the problem as a tooling. Like for example, the tooling engineer is like, did I meet the master line? Is it the OML of the part? Is it the IML of the part that is the issue? But the design engineer is not is like, yeah, if I make a cut there, then I can fix it. For example, yeah, and then you look at it in different like SQE engineer is like, okay, did the supplier meet the tolerance requirements? Let me reach out to the supplier. Let me see what the requirements of the drawing are, and see if the part was kind of like created based on those requirements. So every single person is looking because definitely different minds, different experiences. They're looking at a different perspective. So if we want to solve an issue in a big manufacturing site, as you said, it's not a single person job.
Yeah, it's the whole
It's a
team and like
big
whole
team.
team come
The
together.
the meetings that I kind of held for that issue was like full of like I think we were like 12 people discussing
Well,
senior engineers, quality engineers, design engineers, research engineers, MRB, everyone. So it's
but that's something like that you can only get into an internship and actually doing the stuff that you realize that,
definitely.
because if you're in university and you're just grinding away
Hmm.
um, alone and like with a few people, like even in group project, that's not the skill we're talking about.
Yeah,
We're talking about people with a vast amount of experience in different setup. There's maybe a bunch of intern in there, and all of this we need to figure out the problem for that thing in order to make it move forward. Could be a
yeah,
supply problem, could be a quality problem, could be like a procedural problem. Um, but that's the main shift that
yeah,
you we can see in the from a research perspective, from a purely academic perspective, and the actual work environment perspective. Um,
yeah,
if we switch gear a bit, there's currently a massive labor shortage, right,
yeah.
in the industrial sector, and like it's in on almost everything.
Mhm.
Um, did you see when you were interviewing or like with your peers and stuff, kind of change in behavior from like these big companies relating to hiring interns?
It differs from program to program.
Okay.
Yeah, like aerospace is a bit more challenging at the moment from what I've seen. Definitely, it is a smaller industry. That's for sure. Um, but I've seen that some of the like it's for example it's way more competitive in computer engineering, for example, computer science.
Yeah.
People actually struggle to get to get a good position. But it's kind of the same. Like it's it's super competitive regardless. But as long as you show them that yeah it's not only for internship, if you show them that you went beyond the courses, you went for research, for example, you went for rocketry club, robotics club, I don't know, Formula One club or whatnot. It shows that you're an individual who's eager to learn more than what the person what the university wants you to learn, right? So it shows that you're passionate about the field. You want to learn more. You do not rely on theory only. You wanna put all those theories and all those concepts that you've learned into practice.
Yeah.
And if you show the big companies, they're looking for a fast learner, for a person who's passionate, and is eager to learn. Of course, they don't expect from an intern to be certified for every single software that they're looking for. That's for sure. But if you have them, then definitely your resume will stand out. If not, as long as you show that you're eager to learn, you always want to think out of the box. It's not only you following what a school wants you to follow.
Yeah.
It shows that, oh yeah, this is the right fit for the company. This is who we want to be on the team. We want someone who's passionate about the field, not only.
That's super
Yep.
interesting because one of the core because I've talked like I like to get these insights from different point of view because like
Yeah.
they actually kind of converge toward an answer. But this is interesting because a lot of the concern from like manager or like company owners with regard to intern in a manufacturing plant is like, what are they gonna do?
Yeah.
Like I get that it'll be good for the future and they might come back, but right now I need to have this done, right? And this is where like there's a labor shortage, so they need to have people,
Mhm.
but they don't have time to train people that are not already fully trained. So
That's
you get this weird setup where they need people, but they're not gonna get people with 0.000 experience sometimes because they don't even have the bandwidth to bring them on board. So it seems like if they can get people like you that already come with like a toolkit to figure it out, and then they can actually show that, hey, I've done this and that. I actually figured a bunch of stuff that look complicated, and then they can look at that and say like, okay, well, he's gonna learn for sure in here because he doesn't have everything, but I think he's gonna be able to learn.
Yeah.
I think that's what they're
It's definitely preferable for them. That's for sure. For example, for me, they they never they I don't mean to brag or whatnot, but they never had to. Yeah,
it's the place to do it.
They never had like they never trained me for CATIA. They never trained me for SolidWorks. They never trained me for any of the calculations that I apply for example, stack up tolerance or whatnot. And I'm gonna be full on honest. Yep, definitely. The fact that I studied the theory and I knew the basics helped me to come up with those ideas just in a jiffy and just give it to the team. That's for sure. But at the same time, I have to be full on honest. Majority of them, of those experiences that I applied in the workplace, came from research and rocketry club.
That's it. Yeah.
I'm gonna just conclude it in one sentence.
Yeah.
Yep. I'm gonna repeat myself one more time. Definitely, courses helped. Don't get me wrong. Like every single person gotta take them serious. If you don't know the basics, you cannot go for the advanced aspect of it. That's for sure. But theory just take you so far.
Perfect. I absolutely love this. I think actually it's a good way to end the podcast. It's such punchy line. Behrad, thank you a lot for all of the information that you brought in this episode. I think it will help a lot of people. I think it will help like the students that are getting started. I think it will also help the company owners to see like what an actual person that has this toolkit look like. And what to do about it and how to find these people. So like student club, research lab. Go poach these folks before they go somewhere. Thank you for being here.
No problem.
Uh,
Thanks for having
this,
me.
this has been the Data-Driven Supply Chain Podcast. The information about Behrad's story will be in the description also. And I'm going to put your LinkedIn profile if people want to reach out to you for questions, if that's okay with you.
Yeah, for sure. I'll be more than happy to help.
Fantastic. So have a great week, everyone. And we'll see you in the next podcast.